Now, to reading the structural drawings for the columns. Now, this is the sectioning of the column. You see, this is the sectioning of the column and the column base. This is the column base, and these are the reinforcements. You know, the 6y12 0 to 200b. 1, 2, 3, 4, 5, 6, 6y12. So this is the column base. But we've already treated that, so we are more concerned about the column. Now, this column is what to signify that this is the column that will be in the foundation. From the foundation, let's say this will be the natural ground level or the upper side concrete. But this is the foundational column, and that's what we are concerned with. Although it's the same principle to read the columns all through. Columns, unlike the column bases, go way beyond the foundation. Let's get on to it. So this 4y1601 is obviously like I told you already. This 01, this number 3 is the same as it's an ordinal number. It's just to show you that it's the first in consideration, 01. Then of course here 02 show you that this is the second reinforcement. This signifies a reinforcement, a vertical reinforcement. The column, similarly to the column base, is made up of reinforced concrete. And reinforced concrete, this means it's the concrete, before the concrete is cast, it will be reinforced with reinforcement bars. This is the short form, reinforcement bar. It will be reinforced with reinforcement bars, which is to make the strength of the column, more. So let's get to the meaning. So this is just like there are usually 4. So this is the section. This is another section. This is like an aerial view. You're seeing it from the top. See, 1, 2, 3, 4. Is usually specified by the engineer. So the yield strength of each of this is 16, or there are 16 diameter bars. So 4, 1, 2, 3, 4, 16, 01, saying is the first. Then this second 6y10 0 to 200. 6 here is the number of the reinforcements, while the y10, like I explained here, y is the yield strength or the diameter of the reinforcements. This 02 is an ordinal number showing that it's the second, and this 200 is the space that will be between them. So this 6y is the reinforcement details for the stirrup. You see, these 4y16 bars are vertical, so they need something to hold them together, because if you just put a vertical steel bar, what will happen? Of course, it's to fall apart. So this is the section. Let's say this right here is the concrete itself, or the column itself, or let's say the concrete. But this bar, you see this bar here, this inner square, the outer square is the concrete. The inner square will now be the stirrup. The stirrup is a square member that is used to hold the reinforcement bars. The 4y16 is used to hold them together. So how we now know the amount of stirrup through this 1,200 length? See, it's quite simple. The length is 1,200, and the space between them has been specified by the engineer to be 200 divided by 200. What would that give us? Of course, it's 6. And the engineer specified that the metal should be y10, that's 10 diameter bars. So that's 6y10 for the second bar at 200 millimeter intervals. I don't want nobody to get my back. For this life I did, I want to be celebrated. So Similarly to the column bases, the columns too, there are different types of columns. And this is solely based on the specifications. If you open to page 3 on the structural drawing, which will be displayed on the screen, you can see the column details. Don't be intimidated by these drawings. These are simply the column details that will run through the entire building, but we are only dealing with the foundation. You know, I told you that different types of structural drawings, but we are trying to know how to read the foundation layout. So we are going to go back. Okay, before we go back, CT2, this is the column type 2. CT stands for column type. Wait, bring it here. CT2. So this is column type 2. Since it looks complex, let's read it. This column type 2 will be on base type 4. If you go back, now we are back to our foundation, our part foundation details. If you be on base type 4, you can see there are 2 columns on one column base. So it's just like the others, it's just more cumbersome. It's not even more complex, it's simply more cumbersome. Here, rather than a square stirrup, the stirrup is round. You know here, okay, I've cleaned it. Normally the stirrup is supposed to be like this. But this is a round stirrup, and they specify that there will be 6 reinforcements running through it. And don't just look at the drawing and follow it. Always look at the specification, because if you check the column details here, they only put 4. Yes, they only put 3, rather 3 or 4 dots. But if you check the specification, see that it is 6. So just like we said, 6, which is number 1, is the number of bars, reinforcement bars. So instead of 4, where have you? This would be 6. 1, 2, 3, 4, 5, 6. And this is like the aerial view. This is as if you're looking at it from the top. It will come like this. Then we need something to hold it together so that it won't fall apart, which is this syrup here. The syrup is circular in this case. You know, this syrup. So the syrup 2 will be 6, although even the last one was 6, and the distance between the syrup. So this bar now is 1, 2, and at every 200, there's 1,200 millimeter, and at every 200 millimeter, there will be a circular syrup. 200, 200, 200. So how many will be? Although all these things it will be specified, but we're just practicalizing this so that we get reading it to be easy. At every 200 millimeter, there will be a syrup. So how many syrup will be on each column? See, we say this one Y16 is the yield strength or diameter, just like here, yield strength or diameter. So that's for the reinforcement bars. Then for the syrup, now, 6 norm of syrup, Y10, yield strength, space between. So, and this sorry here, this is 1,200 millimeter long. So it should be 1,200 divided by 200, which will give us 6. So there you have it. That's how to read your column and structural drawing.